Okay.
Hello, everyone. Thank you for joining this seminar series organized by the Empathic Computing Laboratory. I'm your host, Aladdin, and our guest speaker for today is Kangsoo Kim, who is currently an associate professor at University of Calgary. His research interests are in persuasive context-aware XR and intelligent social interaction XR. He has done a lot of great work in HCI and XR since 2009. That's correct. The title of the talk is Increasing Social Presence with Interactive Virtual Agents in Extended Reality. The talk will be roughly an hour, followed by a brief question and answers. Thank you, Kangsoo, for joining us. Handing over to you. Thank you.
Okay, so nice to meet you, everyone. And I'm very honored and excited to be here to present my part of my research. So the talk title is Increasing Social Presence with Interactive Virtual Agent in XR. I'm Kangsoo Kim, and I'm an assistant professor in the Department of Electrical and Software Engineering at University of Calgary. So for those who don't know where the Calgary is in Canada. The state, the province is Alberta. So right over there, kind of like in the middle of Canada, but a bit towards the west coast, close to the Vancouver. But when you actually drive from here, Calgary to Vancouver, it's gonna take like 14 or 15 hours because there's like Rocky Mountains over here. So Calgary is right next to the Rocky Mountains. So since you guys are in New Zealand or like Australia, you know the environment are pretty, the nature is pretty similar, I think. I've been in New Zealand a few years ago, and I feel like a lot of things are pretty common between Canada and New Zealand and even Australia. And then, Calgary is kind of like culturally very diverse. And some people said, Calgary is kind of like Canadian Texas. There's like a cowboy culture here as well. And also the oil and gas, like energy industry is very strong. And basically the foundation of this city, the Calgary. And then my university is the University of Calgary, as you know, and the university is recently, getting the top 5 research university in Canada. So it's very open-minded and then very open to the international collaborations, and more like my department is actually the part of the engineering school, as you can expect, not the computer science. So a lot of things are very focused on the applied sciences. So yeah. And just sharing my brief introduction. So I'm currently assistant professor since last September. But before then, there are some periods that I spent here and there as a postdoc or research interns, including like a US Army Research Lab or Meta, Facebook Reality Lab. At the time it was Oculus, but I spent some time as a UX research intern. And also I spent a lot of time, more than 8 years, almost 9 years in Orlando, Florida, during my Ph.D. and postdoc. And then so I spent almost like 1/4 of my life in Orlando. And then there's a very strong institute, especially for the simulation and training. I was trained during my PhD program there. And then before then, back in the day, like 2010, I was actually visiting students while I was doing my master's, like in Korea. was visiting HIT Lab, New Zealand, and like Canterbury, University of Canterbury, with Professor Billingers at the time. And then my journey with this research, I mean, augmented reality and virtual reality stuff, roughly started around 2008 or 9, that time, when I was first joined the UBI lab. I think you guys might know, so a lot of students actually went to your university from the UBI lab from KAIST now, but at the time was in the GIST, Kangsoo Institute for like Science and Technology. So I spent some time there, and then that's how I started looking into this research area, augmented reality and virtual reality, that kind of stuff. And in a very high level, my research is about like virtual agents and virtual avatars and social interactions with those entities, of course. And I'm looking at pervasive XR and IoT, and also more like the fundamental human perception and cognition and behavior analysis, that kind of stuff. And then I'm sure you are familiar with these kind of venues like ISMA, International Symposium on Mixed and Augmented Reality, IEEE, or CAI. Those kind of things are my ballpark. I published several papers here and there, and then thankfully got some paper, like best paper awards with some of other students and my advisors at the time. Yeah, so that's kind of like a rough introduction myself for your like reference or for your information about me. And then let's start looking into these actual like slides. So today's talk is about increasing social presence with interactive virtual agents in XR. I'm pretty sure you're familiar with these kind of concepts like a social presence or virtual agent, extended reality, those kind of things. But I will start from the beginning as a very like a broad concept description. So we're going to talk about this extended reality, and these days like people use a lot of different terminologies like virtual reality, augmented reality, mixed reality, extended reality, cross reality, or even metaverse. I mean, all those kind of like different terminologies. But as you know, I mean, that's basically we're kind of combining this reality and virtuality. And then, I mean, there are some variations of these like concepts. I mean, some people define mixed reality or extended reality in different ways. But here it's roughly, I mean, I would say like based on the milligrams and continuum, virtuality continuum, there's a reality part, of course, and virtuality part. And in between these two extremes, we're gonna like say like mixed reality area. And then including all these kind of concepts, so let's say it's extended reality. And then the technology is kind of merging these reality and virtual reality all together. But this kind of like a definition or description is very from the perspective of technology, very technical definitions. But what if we putting like humans in the middle, and what does it mean like extended reality to us humans? And then so I would like to ask like what's reality to us? So to me, the reality is basically like all the things that I perceive and feel and learn in the real world. The moments that I share with my family and friends and colleagues. And right now I'm in the reality, even if I'm talking to you in a very remote place. But to me, the reality is a experience as a like a perceptual like concept. I mean, reality is to me more like everyday experience to me. Then what's the extended reality or the technology? I would say the technology is a tool that kind of blurs the boundary of this experience, my experience, and like limitations. And extended reality is basically I would like to extend my own experience, my like daily experience. So, for example, like 100 years ago, like almost like 150 or 200 years ago, a lot of people kind of imagine like dreamed about this kind of like experience. I mean, the talking on the phone, someone else in the remote place while they're watching, while they're seeing each other. And then today, I mean, as we are doing right now on this Zoom talk, I mean, this kind of like technology, this experience is a reality. I mean, a while ago it was just a dream, but now for us, it is a real life, real things happening. So in that sense, I'm talking about like not only just the technical aspect, but my research is kind of very interdisciplinary, including, of course, software and hardware engineering stuff. But also I'm looking at these human factors and user experience based on the psychology or social psychology related to the perception or cognition, that kind of stuff. And of course, technical aspect, I mean, technological convergence is important for me and a lot of researchers as well. So my main research is, of course, this extended reality, or I mean, people call it like spatial computing aspect, how we can actually make these virtual things intuitively interacting with the users, and how we can make that natural in the real environment. And of course, some other components are there, pervasive aspect, how we can make this technology available anytime, anywhere, and physical computing aspect, even if it's a virtual things, how we can actually make these virtual entities interactive to the physical environment, and also vice versa. Physical things should be aware and interactive with the virtual entities as well. And last but not least, but is about the social aspect, how we can make this technology available to a lot of people, and how they can make the connection, like socially connected to each other and socially influenced by this technology. So basically the research goals that I have is how we can develop more effective and influential interactive systems. And through this interaction, how we can enhance and extend human abilities in different ways. And while pursuing this, I would like to understand how humans perceive and behave in VR, AR environments while they're interacting with virtual entities. So speaking of this interactive system, basically user interfaces, as you know, I mean, we have like pretty long history of these user interfaces. I mean, the computing devices. So back in the day, like a punched card or like keyboard, Palm Pilot, like what is this? Like a touchpad kind of stuff, styler based mobile devices. And recently, like about 10 years ago, we've been using, since then, we've been using these voice user interfaces like Amazon Alexa or Apple Siri, that kind of voice user interface. It's getting more and more intelligent and interactive and different ways. And then what would be the next user interface is more intelligent and more interactive and more natural. And I would say, I mean, this embodied interactive like virtual agent could be one of those kind of types. I wouldn't say I don't want to say, I mean, this is the only way that we're going to interact with the computing devices, but this could be, I mean, this will be definitely one of the very powerful and universal like interface that people would use in the future. So as you might know, I mean, the embodied agent have been used in many, many different applications. I mean, the most familiar thing would be like gaming context, like while you're controlling your own character in like games, like FPS, like a first shooting game, or any type of like role-playing games. You're gonna have your own avatar in the game, but there are some other non-player characters, like basically like a virtual agent in some aspect. And of course, a lot of different applications like medical simulation and trainings, or military and education, and even some concept has like a receptionist to greet people in the building. So there are many, many different application areas that have used these intelligent agents, where like a realistic social interaction is required or otherwise very beneficial with this virtual agent. And then we want to look at this interaction, how normally like a human agent interaction happens. Of course, there's a user and a virtual agent. They're going to interact with each other verbally and non-verbally. And then one of the important concepts, I mean, is social influence. I mean, basically, in the previous slide, there are many different applications. And what's the goal of those applications? Basically, we want to make some sort of influence to the users using these virtual agent systems. So that, I mean, in some sense, I mean, the learning, I mean, for example, in an education application, agent could be your virtual tutor. And then the virtual tutor will like kind of try to teach you and make some suggestions, that kind of stuff. And then user will learn from the agent and in social manners. And that could be one of the types of social influence. But in a high level, social influence is basically any kind of like a change of one's emotion or opinion or thoughts or behaviors in this social context. I'm pretty sure you're very familiar with this concept of social presence, which I mean, roughly, I would say like a sense of being together or socially connected. And then social presence is basically like indirect measure to show or like measure this social influence, how much people actually feel they're in the same space with the agent, and then how they feel they're actually socially connected to each other. And then there are different ways to measure this social presence, like of course the questionnaire. We can directly ask their perception related to this social presence with the agent. And also there are some other aspects like behaviors, how much you're going to maintain the social distance with this agent, or how much you actually make the eye contact while you're talking with this agent, that kind of stuff. And also, of course, there are some other physiological signals, like when the agents emotionally affect you, how that kind of physiological signals can be influenced and changed. But the thing is, a lot of cases, I mean, the typical like prior research, a lot of cases, the social influence, in other words, the social presence with this virtual agent is not so strong compared to the real humans or even the robotic humans' social presence. So I would like to look at how we can actually improve this. And then one of the thing that I found is this physical environment. Of course, the user is always interacting with this physical environment. For example, you and I talking on this Zoom, when something happens in my physical environment, for example, like a fire alarm alerts or something, then I'm gonna immediately respond to that, and I'm gonna doing something for that. But a lot of cases of the virtual agent in a typical like application that we develop doesn't really have that kind of ability or the features, the agents to interact with this physical environment. So my research, there are different aspects of my research, but one of the part of my research is mainly focused on this connection between this physical environment and the agent, how we can make this kind of connection, and how these kind of environmental physical virtual interaction can actually influence or increase the level of social presence with the agent. So from now on, I'm gonna briefly show you some of my prior work related to this intelligent agent interaction and this kind of like the physical virtual interaction or interactivity. And I'm not gonna focus on like how we're gonna measure the social presence or how we analyze the data, what kind of like statistical analysis we use, but I'm gonna like more focused on the findings and research. So a lot of research that I conducted involved different measures, as I said before, like questionnaire, subjective measures, and also behaviors. And sometimes from time to time, use the physiology analysis. But a lot of cases that I present today is mostly based on the subjective, the questionnaires. So yeah, so that's what I wanted to say before I move on to the next slide. So first, I'm going to talk about this physical virtual interaction, and one of the research that I conducted with my colleagues earlier, like 6 years ago, roughly 6 or 7 years ago. This is what we call the wobbly table. So the main research question was kind of like, of course, there are different research questions at the time, but the main goal was how does the direct physical virtual interaction can actually increase the sense of presence with the agent. So I'm going to show you this video clip for a moment for your understanding of the concept. So as you can see here, there will be a virtual human in front of you. In this case, it's a kind of like a wide screen, like a back projection screen. And then you're going to like have brief verbal interaction with these agents, like a 20-question game or something. And then there is a table in between you and the virtual agent. The part of like half of the table is in the virtual environment side, and the other half is on your side, the physical table. And then you're gonna see what's gonna happen. Yeah, so while you're talking with this agent, if like, you know, like if you push your table on your side, the physical table, you're gonna see the other virtual side actually respond to that, you know, as if it's like a continuously connected to each other. And also the other way around.
Nice to meet you.
Also the other way around, the agent, when the agent move their hands, the physical part will be responsive to that behavior.
We are going to play 20
It's very
question
subtle.
games. I will start by picking an object.
Yeah. As I said before, it's very subtle, a very subtle movement as you feel. I mean, the motivation of these kind of setting is when you go like coffee shop with your friends, when the table is kind of not stable, then you can actually feel, even if you're not watching, you're seeing your friends, you can actually feel someone is in front of you by that kind of like a vibrotactile, like a feedback on the table when they push the table, and then you're kind of your hands on the table. So that kind of like direct interactivity through this physical table can actually increase your social presence with your friends. So we wanted to check how that actually influenced these human agent interactions. And then we found the social presence and also like a social like engagement or different like measures were actually increased with this kind of like direct physical virtual table interactions. And also from time to time, the virtual agents kind of like exhibited awareness behavior, watching the table and checking the table while the table was moving. And then next study, I mean, we wanted to see how subtle we can actually make this physical virtual interaction happens, and then how that can actually influence the user's social presence with this agent. And then in this particular setting, we call like a physical virtual airflow. This is very indirect. The user is not actually involved in that interaction. So the previous example, the user actually touching the table and directly interact with this physical environment. But in this case, the user will be just merely observing the phenomena. So basically there's there's a human user on the other side, and then the user will be observing these kind of like airflow interaction. So when this physical fan oscillating and the virtual curtains behind the virtual agent or the virtual paper that the agent was holding is kind of were kind of fluttering. So the user will be observing these kind of interactivity between this physical environment and the virtual agents and the virtual environment there. And then the virtual human from time to time exhibit this kind of awareness behavior as well by looking at the physical fan or trying to grab the paper, kind of very simple like behavior. And then we wanted to see how this subtle, much subtler indirect interaction can actually influence the social presence. And then we found this can also increase the level of social presence with this agent. And then I mean, to build this kind of setting, I mean, basically these kind of settings are very ad hoc implementation. So we prepared these kind of like physical virtual table using this computer vision, like a detection of this light, and then make the table movement based on this virtual agent's behavior and the real humans movement. And then for this indirect airflow interaction, we used this Arduino board, and very simple Arduino, and then wind sensor to detect the real fan's airflow, and then make the simulation in the Unity to make the virtual paper and curtains or fluttering. So as I said before, this kind of setting is very like special setting that we need to develop. But so next step, this part 2 is about how we can actually generalize these kind of settings. So the thing that we thought, I mean, is about this IoT based physical interactions. As you know, I mean, these days a lot of people use Amazon Alexa with IoT devices to control their physical environment, like turning on and off light, or to lock the door. That kind of physical interaction can be happened through these voice assistant system these days. And then what if we actually add this embodied virtual human character on top of this voice assistance system, then what kind of effects can we expect? So as I said right before, this agent embodiment and physically interacted behavior is one of our treatment, and then how that actually influence the social presence and also the user's confidence in these agents' ability. I mean, the agents can physically influence the environment, the user's environment, and then whether the agents can be aware of this physical environment in the shared space, and then whether these agents can actually perform the activity for privacy preserving, the user's privacy preserving. So these days, a lot of people concerned about this voice assistant system because of these privacy issues. Because while you're talking with the Amazon Alexa, the Alexa will be always listening to you. So they're kind of concerned about this kind of privacy. So how the users will increase their confidence in these agents' abilities. And then kind of related to that, how this embodiment and physical interact behavior can actually influence the user's trust in this system, the reliability and helpfulness of this system. So we prepared the 3 different conditions in this the study. So first condition is about this disembodied condition, speech only, basically similar to the commercial voice assistant system. And then we have 2 different conditions with these virtual characters. One of the condition here, the virtual character, the virtual agent only have these upper body gestures. She was not walking around the space in the shared environment. And then last condition, she was actually walking around the space and then mimic the human gestures while the agent was interacting with these human users. So in this case, it's basically the turning on or off the lamp. The human user will ask the agent to turn on or turn off the light. And then the agent, I mean, the first case, the voice assistant will just reply back to the user, sure, will do. And then the lamp with the IoT features will respond to that command. And then the second one is the agent was just standing, but kind of pretended to use some sort of like a remote control or something. And then when the agent clicked something on the virtual remote control, the light, the floor lamp will respond to that. And then last condition, the virtual agent was actually walking towards the lamp and then try to switch the button on the floor lamp, and then the lamp will be respond to that using this IoT feature. And then the research was quite interesting. Of course, I mean, when we look at this social presence, of course, when the users were able to see something in front of them, the level of social presence was increased compared to the voice-only conditions. But interesting thing is when the virtual agent was actually walking around the space, and then the agent, the users was watching the agent behavior, interacting with this physical object, we found the level of social presence has been increased significantly more than this previous, I mean, the without this locomotion behavior. The interesting part is actually in this confidence or the confidence and then trust measures. So disembodied condition compared to the embodied condition, I mean, we couldn't really find the I mean, statistically significant difference between these embodied and disembodied conditions. But the interesting part is when we have this locomotion behavior, the agent was walking around the space, we found the participants in the study actually reported they have a higher confidence in the agent's behavior and the agent's ability towards this physical environment, basically the influence and the awareness and the privacy preserving the aspect has been significantly improved. And then people found the system was more reliable and helpful in this last setting with the agent with locomotion behaviors. So we found these kind of interesting observation. And then for example, one of the scenario that the users interacting with this agent was, for example, like a leave me alone kind of setting, like can you give me some privacy or something? And then at the time this last condition, the locomotion agent condition, the agent was actually, okay, I will give you some privacy. And then she was actually, she left from the room. And then we know, I mean, everybody, I mean, everybody was aware that the system is still in there in the physical world. But by observing the agent moving out from the space, that could actually make the user more like comfortable, and then they thought the agents kind of provide the privacy to the users, which was quite interesting to us. And then when we think of these commercial like voice assistant systems, there's a good kind of like there is an important implication how this embodiment can actually play an important role to reduce the privacy like concerns, even if the system is still watching and listening to the users. And in summary, we found these agent embodiment, not only just embodiment, but this physically interactive behavior. I mean, walking around about the space and physically touching or like changing something using this like non-verbal behavior could actually increase the level of social presence and confidence, and also the trust in this human agent interactions. So part 3, I mean, so far we've been talking about like ad hoc settings of these physical virtual interaction and how we can actually generalize these kind of physical interaction of the virtual agents. And then what's the meaning of this? How we can actually use these kind of agents, embodied agents, to improve the user experience and enhance human abilities. There could be different application areas, but I would like to mention a couple of areas that I explored before. So one of the application area could be this healthcare aspect. XL, I mean, virtual patient care assistant. I mean, a lot of patients are actually suffering this physical discomfort or disability and hospital settings. And actually, as you can see here on the like top image, there are some company actually try to install these the voice assistant system, Alexa, in a hospital, so that the patients in the patient room can actually communicate with this their healthcare providers out there, or they can actually like control simple physical things around the patient room. And then we actually used the same concept in the previous study, basically the embodied agent with this physically interactive behavior. We wanted to see how this interaction with this virtual embodied agent can actually influence or affect the user experience and satisfaction in the context of this patient care assistance. So we compare these 4 different conditions: virtual embodied and virtual voice conditions, of course. And then we actually try to use these real embodied human and real voice assistant compared to this virtual agent to see how these virtual agents interaction with these virtual agents are kind of like a similar level to the real assistant settings. So, I mean, the nutshell, the high level description of the research. I mean, there are different scenarios while the users are interacting with this virtual agents. They had some medical tasks, like for example, like very simple medical tasks. The agents asked like a vital check. If the agent was performing like a vital check. I mean, we didn't actually do that, the actual vital check, but basically the mimic the behavior of that kind of a vital check, and also the access to some exercise with these patients, the participants who play the patient role. And then like the exercise task involved like light stretching or like breathing exercise, that kind of stuff. And then after all, we measured their willingness to use one of these systems. I mean, the virtual embodied or voice agent, or the real human assistant, or real human's voice. And then we kind of compare their willingness to use one of these systems, one of these service, I guess, yeah, services. And then of course, the real human was highly preferred for the medical tasks. I mean, as I said before, vital check or like a blood test, that kind of stuff. People still wanted to use the real human assistant. But embodied case, when we compare these voice only and the embodied conditions, we saw the like people prefer the embodied agent, either, I mean, both the virtual case and the real human case. But it's kind of obvious in some sense, because you can actually see the agents like showing this light stretching motion or breathing kind of exercise with this agent. And then people kind of preferred and wanted to use this embodied agent condition for those exercise tasks. And then we also measured like a usability and engagement or satisfaction, several other aspects. And then as you can see here, I mean, this real human case and then virtual agent case, most of the things, I mean, real human agents were highly rated. I mean, usability and satisfaction and engagement. And also embodiment, it was embodied agent or embodied assistant condition was a bit higher compared to the voice only conditions. But one thing that I wanted to point out is the virtual agent condition compared to the real assistant conditions. You're gonna see like the absolute score was not that low. I mean, compared to the real assistant. I mean, it's pretty high. I mean, in most of all these measures, like usability, engagement, and satisfaction, it's slightly low, but it's still very comparable with this real human conditions. And also when we have this embodied virtual assistant in this patient care context, actually the real human's voice condition, when the real human was actually talking on the phone, basically to help the patient remotely, then the embodied agent was actually higher, I mean, compared to this voice real human condition for engagement measures. So it was easier for them to be engaged in the interaction with this virtual agent patient care assistant. So yeah, that's one of the study that we conducted and then found interesting research, which we concluded the virtual agent could be viable solution for that patient care assistant compared to the real human assistant, considering the cost and depending on the task. If the tasks are very simple to perform, then the people kind of prefer to use these virtual agent assistants. And then next concept or scenario is basically the personal assistant, especially for the for collaborative decision making. And then a lot of case, I mean, for example, when we drive our car using GPS, we are relying on the GPS. I mean, GPS is not like artificial intelligence, but in some sense, it's a kind of like it's providing this information to you, and then you make the decision based on that information that the GPS system provides. Then what if we have these virtual assistants as a collaborative partner or like personal assistants? So we set this desert survival task in augmented reality. So for those who are not familiar with this desert survival task, so there are 15 items that you need to prioritize for your survival in the desert. And then there's actually absolute solution that the desert survival expert provided. So there's you can actually score your performance in this desert survival task by comparing the solution provided by these survival experts. And then the user will prioritize these items. So you basically, they're gonna place these 15 items in this augmented reality setting. So they're gonna see which items they placed in order, and then there's some description about these items. And then similar to the previous studies, we had these 3 different conditions. No agent condition, basically the participants, the user was performing this survival task alone themselves. And then there were 2 agent conditions. First one is a voice agent without this visual embodiment. And then the third one is this embodied agent. In this case, the agent was kind of like a miniature. It's not like a human real size, real human size, but kind of miniature on the table. And then the agent was able to walk around the table and then pointing the items and then make some facial expressions and gestures while the agent was making suggestions for the users. So basically, while the user is performing this task, the agent would say like, "Oh, I think the water would be more important. Why don't you move it up?" Or, "I think some item is not so important. Then why don't you move it down?" That kind of suggestions were made by this embodied agent. And then the research, we compared their performance. As I said before, we can actually calculate their the survival task performance objectively by comparing the expert's solution. And then here the best score is 0, basically the same as the expert's solution. And then there's a minus scores, which is bad scores when you go down. And then we found these when they perform this task alone on their own, I mean, without any other information, of course, their task score was low compared to these two agent conditions. So voice agent and embodied agent, both conditions actually increased the user's task performance in the desert survival task, which is quite understandable, because they can actually have other opinions from the agent. And by the way, the agent was always making positive suggestions. So if the user was actually following, if they followed the agent suggestions, they're gonna have better scores normally. I mean, and that, but the whether they're gonna follow the agent's suggestions or not is totally up to the users. So some people thought their solution, their answer was pretty nice, then they didn't follow the agent. That's what we guided from the beginning in the study. Yeah, so we found this increased performance for both voice and embodied agent conditions. And then here's the interesting part. We also measured this task load. I mean, basically the cognitive load using the NASA TLX, and then we found this increased task load with this voice agent condition. So which means, I mean, they have to deal with these other opinions, opinion or suggestions from this voice agent. So they need to think again, and then there was increased cognitive load in that sense. But interestingly, when we use this embodied agent, the task load was actually decreased, almost similar to the no agent condition. I mean, when they performed the task alone, they didn't have to consider other opinions, so they just follow their own like feeling. So they didn't have to, like, of course they need to make the decision on their by themselves, but the cognitive level was pretty low compared to the voice agent condition. But with this embodied agent, it actually goes down to that level when they perform the task alone. Interesting. This was pretty interesting to us. So with using this embodied agent, people can actually improve their performance, but still with the low task load or cognitive load. After all, I mean, when we asked the reasons behind these like cognitive level, a lot of people actually mentioned they were more comfortable to understand the agent suggestions. I mean, of course, the agent was pointing the certain items, so it was easy to find the items that the agent was talking about. And also using these facial expressions and the non-verbal gestures could actually improve their, I mean, the comfort and then trust in that agent system. So it was kind of easier to perform this task with this embodied agent. So in summary, this physically interactive embodied virtual agent could be very powerful interface or medium to improve or enhance human abilities. And considering the cost effectiveness, I mean, compared to real humans, it's a very viable solution which can provide higher social presence and engagement compared to the existing voice agent systems. So that's pretty much all of the studies that I wanted to show you today related to these intelligent virtual agent interactions and improve the social presence and kind of like in general the user experience with this agent system. Of course, there are some other research that I performed related to that I conducted related to these enhanced human abilities like visual acuity in VR or AR and extended sensory perception using IR and UV visualization in augmented reality. Or I assume a lot of you guys already work on this remote collaboration kind of concept in VR and AR. And then I conducted some of the research related to this social cues, sharing social cues in AR as well, related to this gaze visualization. And also some of the research is related to this multimodal activity analysis as well. So I think I spent too much time, but I will quickly talk about the current and future directions that I'm thinking and that I'm currently working. Of course, I mean, the future will be very intelligent. I mean, the future of this XR area, we're expecting very intelligent, interactive virtual agent systems. And then considering this artificial intelligence and immersive, like extended reality and ubiquitous computing, Internet of IoT paradigm, I'm looking at this convergence of these three areas. So highly intelligent and interactive XR interfaces will be very useful and beneficial and important. And then the understanding human perception and behavior will be highly required to make this technology available in our daily lives. And then I'm looking my research interest continues in these areas, like, of course, developing these multimodal agent systems, and then how we can actually visualize things and then understand the human perception in different settings, and then digital twin and IoT, and how we can use XR interfaces, entities, and industry settings to for maintenance or collaboration and training aspects. And as I said before in the previous slides, healthcare applications are quite important in this area. And of course, the entertainment and education. And these days, a lot of social influencers are, I mean, there are many virtual influencers out there already, and then maybe we're gonna have more interactive virtual influencers in the future using this VR and AR. And then in a high level, I mean, the broader sense of this technology in the smart city or smartly connected communities, we're gonna use these AR or VR to maintain or design the city or community and share the information between the users in the community. And then related to that, I have currently working, I have some projects that I'm working on with my students. I mean, there are some other projects, but some of them are here education stuff. So now I'm currently working on this realistic on-farm experience in VR. So a lot of like farming experience, virtual farming experience is very cartoonish or like for mostly for fun. I mean, it's more like a gaming context, but here we wanted to show realistic what actually happened in the dairy farm. So we're gonna mimic this real scene in the dairy farm, and then how that experience in VR can actually change the user's behavior to purchase a certain product, like what kind of milk they're gonna buy after experiencing this realistic farm. And also there are some facility here in plant information and experience can be shared in this indoor garden environment using the VR, AR. And then I'm currently working on this infrastructure, how we can develop this XR infrastructure using IoT devices and 3D reconstructed environment for our campus, Universal Calgary campus. And then there are some industry applications for the training and visualization, and then interaction and perception using like virtual dogs or understanding human violent behavior in VR. Yeah, that kind of stuff is my, the projects that I'm currently working with my students. Yeah, so this is the last slide. So I'd like to thank all the collaborators and colleagues and my former supervisors and current colleagues, including Mark Billingers, Professor Mark Billingers, and these are my current students and the former like colleagues. And then a lot of work that I showed today is supported by Office of Naval Research in the US and National Science Foundation, and the recent work is supported by the NSERC, the Canadian government, and some other funding sources. Yeah, I would like to thank them all. And this is the last slide. So sorry, I spent too much time, I guess. I don't know. I mean,
No,
the original.
That's perfect. Well done. Thank you. Thank you very much, Kangsoo. I learned a lot, and I guess now we open opportunity for people to ask questions. But I have a question to start with.
Sure.
So you try to, in your previous experiment in the like Wobbly table or the airflow or the IoT agent, you found that some tasks that people do not trust the agent or the social influence is not as high comparing to human. Do you think there is something that the virtual agent we can program them to do, or if there was an artificial intelligence to figure out or to mimic human, would they trust it more, or was there something else?
I think there are different aspects. I mean, I don't know when we're gonna actually have that very, very high level artificial intelligence, which is similar to the real human. But if we're gonna have that, if we have that kind of like a very high quality, almost like agents that passed the Turing test, then I think the reliability or trust level would be similar to the real humans in that interaction. But I think it also, even if we have that kind of agent system, in that case, the trust or the social presence or influence will be more like related to the context, the social context that we have with this agent. I mean, even if we have like a human-human interaction, for example, you and I just, don't get me wrong, I don't want to offend you, but you and I meet here for the first time, your trust level and my trust level, it relates to each other, might not be that high compared to my trust level with my wife and kids. So there are different components will be influencing in that agent to human agent interactions. It's more like a human interaction, similar to the human interaction. So I think there are different components in that sense. I mean, from the perspective of the social aspect, but trust, I mean, yeah, that's kind of like one aspect in terms of this social trust aspect. And the other aspect is more like a technical trust. I mean, trust in the system. There are different meanings of this trust. Trust is really difficult concept to define. There are different ways and different models to define the trust. Like when we talk about the trust in this kind of like a machine or system, there are different components like reliability and performance and security, that kind of stuff in the system. So in the system level, confidence or the trust, I mean, it really depends on the user's understanding or the perception of this system, I think. If you treat or if you're really think, even if it's really visually perfect, more like a realistic human virtual agent, some people might still think or perceive it, oh, that's not human. I'm not going to believe this system because it's not, I know it's not human. That kind of like a perception will play in this development of the trustworthiness of the system, I think.
Yeah.
I don't know if I can, I don't know if I answered that, the question, but I'm just trying to share what I was thinking. So yeah.
Yeah, I understand there are many factors involved in this. We have a question from Juan.
Yeah, thanks, Kim. It's really a nice talk. And actually, I'm really interested in your research. For the desert, So for the AR desert survival game, I have adapted this game to VR and measuring the cognitive load with EEG cap. For conducting this experiment, I encountered some problem. For example, the learning effect. I remember that in your paper, you also use the VC study design, right? How did you handle the learning effect? For example, one participant might experience the voice-only condition, then the embodied condition, and they may remember some of the suggestions from the agent. I guess that maybe you also encounter similar problem, right?
Yeah, I mean, especially this kind of like a virtual human interaction study is quite difficult to run. I mean, because I mean, for example, if it's just a user interface and it's kind of like doing the same test again and again, it doesn't really matter that much. But if the study involves like a social aspect, if their perception in the first interaction with this agent could be strongly interfere or influence the next interaction. So I don't really have like a good answer for that, but the way I try to do, and then the way I learned and try to do with my colleagues are trying to make that kind of interaction kind of independent, so that we can kind of try to avoid that kind of influence learning effect or like unexpected influence between these multiple experience. I don't really have like a good answer for that, honestly. But in my case, I try to use the within subject to study still, kind of try to do that a lot. I mean, if the first interaction is significantly like ruined the next interaction, then I cannot really use that within subject to study. But otherwise, I mean, if the involvement, I mean, the interaction and influence between these multiple interactions are like, I don't know how to say, like, not subtle, but manageable. I mean, that's why we are running the study with this counterbalance or like different ways to avoid that kind of effect. But we increasing the sample size and then maybe take some time between the stimuli. I mean, after like a 1-day experience and the next day, that might help. But I honestly don't have like a good answer for that.
Okay, thank you. And a similar question is that your virtual agent provides suggestions based on the expert knowledge, right? And what if the participant knows that this suggestions, suggested from the agent is from expert, so they will not think about the decisions. They just obey the agents. Or on the other situation that participant just ignore what the agent is saying, or the agent's behaviors like gestures or facial expressions. So how did you handle these situations in your experiment?
Yeah, I mean, for the first question is, I mean, we gotta just know whether the participants actually know the task before the study or not. I mean, before the study, we just check. I mean, it's basically like checking whether they experienced the desert survival task or similar survival task before. And then if they already have that kind of experience, we kind of remove the participants from the pool. And that's something that we need to do anyway for the kind of like a manipulation check or the participants check. And then the second, what was the second question again? Sorry.
Yeah, second question is that some participant might just ignore. Ignore the virtual agent.
Yeah, I mean, that's not something that we cannot really control, or I think that's a fair condition. I mean, if they want to ignore the agent totally, then we need to understand why they want to ignore the agent. That's the research, I think. I mean, someone might totally ignore, and then all the conditions, they don't care about what the agent said. And then that's why we always have like after a study, we're gonna have like a brief interview, and then we're gonna ask why you ignored that kind of interactions at all. I mean, if from that response, we can have very important knowledge or information from the agent, from the participants. But if the participants' answer is just like I don't care what the agent said, I don't like agents, then it's not really meaningful. So in that case, I would just say remove that participants. But if it really depends on the reasoning behind that kind of ignorance, I think.
Okay, thank you. And last question. So I think that most of your research is about one user and one virtual agent. Do you have any plans or suggestions for researchers conducting multiple users with virtual agents? For example, they adopting virtual agents for human-human face-to-face collaboration or human-to-human remote collaboration. Do you have any suggestions or ideas on that?
Yeah, I mean, a lot of studies that I conducted, as you just mentioned, are focused on the one agent, one human interactions. But the reason behind that is when I have like a multiple participants, then it's kind of difficult to control. I mean, I don't know whether the one participant's response is because of the agents or the other partner's reaction. So we got to be very careful about the study design, how they can actually influence each other. So that's why I kind of like try to control that kind of possible influence from the other participants. That's why I have like a one-on-one interaction. But of course, there are some studies that I conducted with the multiple the agents or the participants. But in that case, I mean, for example, like one of the study that I was not the lead author, but me and my colleague conducted, we call it like a social presence or social effect, like basically how the social presence can be contagious towards the other human. For example, I was interacting with the agent, virtual agent. And then before I was interacting with this agent, I observed this agent was interacting with someone else, or the agent was interacting with some other virtual agent. I was just observing that kind of interaction before I actually jump into that interaction. Then how that actually influence that kind of like a mere observation of social interaction of these virtual agents, how that influenced my perception of the social presence with this agent. So in that kind of setting, I had that multiple agent or the multiple human interaction settings. But as I said before, it's kind of like you got to be very careful about that study design, because we don't want to have like a unexpected influence by other interactions. So we got to very careful to control that kind of interaction. If the multiple participants have the interaction with the same agent, I mean the as I said before, I'm not sure my perception is because of this agent or my friend was talking to this agent. So that's what I'm trying to say. But I'm not saying like we should do only like we have to do like a one-on-one interaction. But there's some important things that you gotta understand how you're gonna control that kind of unexpected influence, anything.
Yeah, thanks. That makes sense.
Thank you, Shmurry. We have a question from Rico.
Yeah, thank you. Thank you for a nice talk, and it was very interesting for me that the users can feel more trust when users see that their virtual agent is interact with the real object. And I really curious about how their virtual agent's appearance changes its impact on their users' feeling. For example, when user's appearance is changed by their real object. I mean, for example, when a user's arm is hit something and the users can see that the virtual agent's arm it looks hurt, or maybe when the virtual agent is spill some drink and to their clothes and the users can see that the virtual agent's clothes is drenched. Maybe I thought that the user's feeling will be changed compared to their without any appearance change. So how do you think about this idea of that?
So let me just clarify if I understand you correctly first. So when you say the virtual agent's appearance change depending on the physical interaction, so when you mentioned that like water spilling or like a liquid or something, is that the physical real water spilling on top of the virtual agent body, or?
No, sorry for that. So as for the drink, maybe it's in virtual, but at first I said that the maybe virtual agent is hit the real object, and when users can see that this agent's arms looks hurt, maybe users can feel that this virtual agent is affected by the real object, and afterwards like that. So yeah, I'm saying about how the appearance changing caused by the real object is impressed on the user's feeling.
Yeah, I think that's a very interesting thought. And then one of the, I mean, how can I put this? So what I'm trying to say is not necessarily only about the virtual agent interaction, but in general, I mean, that's what I have like a very last slide. I have like one of the bullet points as in my current project slide, there was one bullet, physically plausible augmented reality bullet. So that project is kind of related to what you described. I'm very interested in that kind of like a physically plausible interaction. So when the agent hit something, or like even if it's not agent, I mean, for example, we have like augmented reality embodiment, and then I have like a physical table here in front of me, a real table, and then maybe I have like glass, or like, let's say a mirror, and I have like a physical mirror in front of me, and then there is some virtual ball or something, and then I'm gonna throw my virtual ball into my on my physical mirror. Then of course this ball will be like, I mean, if we know this physical environment, the information of this physical environment, and then I can actually bounce my virtual ball on top of this mirror. But if the ball is very like a solid, like a metal ball, and then if I throw this towards, I mean, I'm saying like a virtual ball, virtual metal ball. Sounds weird, but virtual metal ball throw on the mirror, physical mirror. What kind of things should be happening? Like I have a virtual ball, but it cannot actually break my physical world, right? So the thing that I kind of thinking is we're gonna have like a virtual mimic. We know like we do like a 3D reconstruction, or we know all this physical environment. And then what if we have like a virtual object on top of this physical mirror? And then if I throw the virtual metal ball on to this physical mirror, and then the virtual mirror, which is a replica of like a kind of a digital twin in a sense, and then the virtual mirror could like show that kind of effect, like visual effect, like a breaking effect, like shattering all the pieces of the mirrors on top of this physical mirror. Then how that can actually change the user's perception and their sense of presence in this space. It's kind of like difficult to define the presence in augmented reality, because I'm here in physical world, and then there are some virtual things in front of me, including like a virtual agent or whatever. And then where I am, I'm in a physical world or I'm in a virtual world, I'm in between. So that kind of like perception of presence will be related to these kind of physical virtual interaction as well. So in that sense, I was thinking the agent interaction is pretty much the same. I mean, if the agents have like a physical influence, I mean, the physically plausible like effects on their hands or like some of their body, I think that will definitely increase the sense of social presence, or in a high level, like realism of this agent. Yeah, so I think that's a very valuable question that I also want to answer. And then, but one thing that I point out is, I mean, I've been talking about this social presence a lot, but my goal is not necessarily increasing the social presence. Our goal is basically want to increase or improve the influence or the user experience. Even if we don't have like a high level social presence, we can have like a high impact of this agent. I don't really care about the social presence, but the goal is actually the influence. What kind of things we can actually get from this interaction, like physically interactive interaction, and how that actually influence the performance or task or learning effect. That kind of like influence is more important, at least for me. And then social presence or those kind of things are just the measures that I want to like explore to prove that kind of influence, I think.
Okay, thank
Yeah.
you for that.
Thank you for the
Yeah,
question.
thanks a lot.
Anyone else? Any other question? I have one question I guess I want to finish with, but thank you again, Kangsoo. So
Sure.
I like how the subtle, that the wobbly table and the like the observation of looking at the airflow. Are there anything else, or sort of like, do you have design criteria for when people are designing these virtual agents to say, okay, to put these in mind, and this will increase the connection with this virtual agent? Are there any other sets of behavior that you think the virtual agent should do with the surrounding environment that would be useful for the future?
Yeah, that's really a good question. It's really related to my previous comments as well. I like to see the influence, not necessarily about the measure, focusing on just the measure. So, but at the same time, it's very difficult question for me to answer, because I honestly don't know. It's really difficult to make that kind of like design guidelines. Of course, there are some papers, I mean, even myself, and I think you're gonna do that same thing, like in the paper, we kind of try to provide the useful design guidelines in virtual human or whatever the augmented reality or virtual reality applications. But at this point, for me, it's really difficult to make firm answer for that kind of design guidelines. What I can say is very simple, as you all, I mean, everybody can say it without any kind of like evidence that the agents should be like at least pretend to be aware of this physical environment, and then try to avoid things in the physical environment. That kind of thing is very superficial, I think. So I don't want to say that kind of like a superficial design guidelines, but instead of that, I wanted to say like, how can I put this? Not related to increase the social presence, but I mean, what I wanted to say is it's really depending on the interaction scenarios, the realism. I'm sure you're familiar with this kind of like saying. A lot of people or famous researchers mentioned that realism is kind of like a wrong word in some sense. Some people say like a believability, but I think it's not also really good a word. But for example, like I conducted one of the study that I conducted is related to the virtual humans passing through behavior. So, but of course, virtual human doesn't have like a physical manifestation, so it can actually pass through this wall or door. How that actually impact your level of social presence with this agent when the agents just don't care about this wall and then just pass through, like the movie, you know, the Vision character, Vision character in the Avengers. He can actually like pass through all the walls, but I mean that's kind of weird. It's not realistic, but people, if the people understand it, the characters or the special like ability of that character, then people understand, and then they understand and also they think it's cool and like a very good feature for that virtual agent in that setting. So, I mean, the user perception and behavior will be totally depending on their prior knowledge and perception and understanding of the context, I think. So that's more important, I think, to design the virtual character, not just to improving the social presence or something, as I said before. Sometimes the social presence is not so good. I mean, sometimes if, I mean, I think you, well, some of you already know that, but some of the research shows like, what is that, like a self, I mean, the exposure behavior. So if you have like someone like I'm gonna tell my private information to like virtual agents, but I'm not going to tell my private information to other users, something like that. So sometimes it's the social presence, high social presence doesn't really help me to do some like tasks. For example, like in a patient monitoring context, patients need to say their personal information, how they feel, and then how much they feel pain, but they sometimes hide that kind of symptoms and to the healthcare providers. But in that sense, like a relatively low level social presence, less realistic, like virtual character would be more helpful to get their feedback. So, I mean, yeah, I don't really have like a clear answer for that design guidelines, but what I wanted to say, like, it really depends on the interaction scenarios and then what kind of things we want to improve in that context, I think.
Yep.
I really agree with you that sometimes the social presence is not needed because the previous research has proved that the embodiment of the virtual agent might also cause distractions from users.
Yeah, I totally agree. And then, as I said before, the title of today's topic is increasing the social presence. But I mean, I'm showing the how I increase the social presence, but at the same time, I mean, I'm more focused on the influence, and then social presence is just a measure. So yeah.
So maybe for designing virtual agents, people just need to consider their situations and bear the uncanny valley effect in mind should be helpful.
Yeah, I think so. And I mean, in my humble thoughts, I don't think I have enough experience to make that kind of like a design guidelines at this point. And I think the samples are very small at this point. I mean, not only myself, but existing the research, I mean, the literature is not that enough, I think, for us to make clear design guideline, especially in the context of this virtual agent, like embodied human-like agent system, because it really involves a lot of aspects, of social aspects as well. So it's I mean, for decades, I mean, social psychology, social scientists have been working on this understanding human behaviors and perception in social context. And there are tons of things that we don't know, but we're just beginning of this new era with this virtual agent. So we just need to catch up all the history of social science literature in that. I mean, apply that kind of informational knowledge in the context of this human agent interaction as well. So I honestly don't know.
Thank you. Any last question from anyone? Okay, I'd like to thank you again, Kangsoo, for sharing your thoughts, your previous experiences with us. We learned a lot, and it's fascinating to learn about the virtual agents and how we can build a better integration between our extended reality or our reality and the extended reality.
Yeah, sure. Thanks again for inviting me. And there should be many like collaboration opportunities. So I know Mark, I mean Professor Billinghurst and Professor Lee as well. So we'll find a way to make any collaborative work together. So
absolutely, would love opportunity to work with you. And if you get to visit New Zealand, please get in touch. We would love to host you here as well.
Yeah, same for me. So let me know if you happen to be here in Canada or in Korea. Yeah, we'll chat about that again. Yeah, thanks a lot.
Sounds good. Thanks, everyone.
Yep, thanks. Bye.